Okay, so today we're going to talk about compound inequalities. We'll skip over this. All right, a compound sentence in English has two independent clauses, right? You can see in here, I drink green tea, and then they drink coffee. And it's joined by this right here, in this case, the word but. So those two clauses could stand alone as a sentence, and they're put together to form a compound sentence. So we're going to do the same thing today with inequalities. These are two inequalities together as one. So a compound inequality is two or more inequalities graphed together on the same number line. So really two just kind of put together. And there are two types that we will discuss in this lesson. The first is an or inequality, so two inequalities joined by the word or. And you'll notice both of them here are graphed on the same number line. So let's write out what these two inequalities on this number line are. So the first one on the left, you can see that is x is less than or equal to -4. And then the other one, well, I'll do maybe a different color here, is x is greater than 1. And these, you can be on this either here in this region or in this region. It doesn't matter. Either one is okay. So it doesn't matter. So we use the word or. It says it's okay to be in either of those shaded regions, and that will qualify as a solution. So this is called an or inequality. When you are given two inequalities with the word or in between, you just solve both parts, and then since it can be one or the other, you're going to graph both solutions and put them both on the number line. So that's kind of a key component. So let's take a look. What does this look like? So here's two inequalities, and you'll see they are joined by the word or. So what we're going to do is just simply solve these like we normally would. So in this case, subtract 6 from both sides. And we get negative x is less than or equal to -1. And then over here, I'm going to do subtract 7. I think I'll go slightly smaller there. Okay, subtract 7, subtract 7. All right, so we get 9x is greater than 36. And now we want to divide by 9 on both sides. We're dividing by a positive number, so we're going to keep our inequality the same here. Just keeping track of that. Okay, so now in this case, it says here we can do one or the other. So these are joined by, again, the word or. So when I graph these, I'll keep with the purple to start. So x is greater than 4. So that's an open circle, and then it's everything shaded this way. Okay. And then we also have this part right here that we've got to deal with. So that's x is less than or equal to -1. So less than or equal to, so -1 is included, and then everything shaded less than. And it can be in the purple region on the right there, or in the red region that we just graphed. Either one will work, and that's why we join it with the word or. Okay. So there's one. So same thing. Here's another one, just a little bit different. Okay, so subtract 8 from both sides. We're just going to solve each of these independently and put them both on a number line, which looks like I'll have to draw here. Okay, and now I want to divide by -3 on both sides. And here I have to be careful because I'm dividing by a negative on both sides of the inequality. I do need to flip this inequality, right? So be careful of that. Don't forget about that key rule. Okay, so there's our first one. And then let's do our other one here. I'm going to add 3. Okay, and I have 10x is less than or equal to negative 30, so I'm going to divide by 10 on both sides. Now, because I'm dividing by a positive number here, it's okay that the 30 is negative, but negative 30 divided by 10, 10 is what we're looking at there, so that's not going to flip the inequality here. So I get x is less than negative 3, or equal to negative 3. So this is an OR situation, and I'm just going to draw my number line here. Okay, we'll just put 0 here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's pretty good there. Okay. So now I'll just graph what we have. We have x is greater than 5, so open circle. We'll shade it this way. And then x is less than or equal to negative 3. And so closed, and we're shading everything this way. Okay, again, it can satisfy either in the green or the blue region is going to be just fine. All right, so and inequalities, so that's an or inequality. And inequalities, when we say the word and in English, it means it has to satisfy both parts. So this one is a little weird. There are really two parts to this one. Here, I've got this section here where the value is greater than negative 2, but I guess it's greater than or equal to negative 2. And I have this other section here that I'll put in green where it's less than 5. And now, if we were using an OR, this would go to negative infinity and then all the way up to positive infinity. But because we are saying it's got to satisfy both parts, then that means we're only going from here to here is the only part where they both overlap. So that's really what we're looking at. And there's a couple different ways to write this, but one is the blue part that we have here is x is greater than or equal to negative 2. And then the other part, the green one, is x is less than 5. Okay, and the key part is because it's the word and in between here, it's where they overlap. So that's this section, as I just said, that's in here. So those are our two inequalities that are represented there. And well, let's get my eraser here. Maybe make that a little bit bigger. And we have a different way to write these. So this up here, we can rewrite in condensed form. And this is really where you put it all together. So when we do that, I'm going to put this x here in the middle. So I'm going to rewrite these up here in condensed form. So I'm just going to put them down here. And if I just look at this part right here, I can just copy it and go, all right, like this. Okay, piece of cake. Now, if I take this other part, I want to put it on the other end of this and put them together. But because I already have the x right here, I'm going to have to flip this thing around. So what I'll do is take the x. So I'm going to just, if I flip this around, right, it's going to look like this. So then I can just take this and put it right here because I already have the x in the middle. So really, all I need is this and the negative 2 here. So now I've just taken this part, put it here, and this part, put it here. Remember, these two things mean the same thing. And that's why I can do it. This right here is called condensed form. And so you can go back and forth between this and these. You should just know that they mean the exact same thing. So, okay. So kind of confusing, but you're going to see and inequalities with both versions there. So if they're both written out and separated, then you're just going to solve both parts and you're going to graph the overlap. Because we use the word and, it has to be where they overlap, okay? If it's condensed, like I just showed you, then that's a little bit different. You're going to solve it all together and you're going to work your way inside out, and you'll graph and shade between the endpoints. So that might not make sense right now. That's okay. But let's take a look at both and how they work. So here is an example where it's split apart. Okay, and so then we will just solve both of these inequalities. So subtract 3. And then I have 2x comes down. These cancel, is greater than negative 12. Divide by 2, divide by 2. We're dividing by a positive 2, so we're going to keep this. All right. And then we're going to go over here. Okay, add 2 to both sides, we get this. 8x is less than 32. We're going to divide by 8. Okay, so x is less than 4. And this is an and problem. So that means we need to put both of them where we want to really just graph where they overlap. So I'm going to kind of write this above because I know my final answer is going to be a little bit different. So this is where x is less than 4 is everything this way, right? There's 4 and everything less than. And then the other part says here that x is greater than negative 6. So I should do it up above here. Here's negative 6 and everything greater than that. So now because this is an and situation, what I want to graph on my number line is actually where they overlap. So from here to here, you can see is where the green and the blue overlap. So that's what I'm going to put actually on the number line. But I want to keep the endpoints the same. So this is still going to be open circle at negative 6 and open circle at 4. And then everything in between is where they would be both. So our solution region is the red there when I would graph that. So you can see you solve both of them and then put on your final answer, you want to put where they overlap on your graph, on your number line. Okay, so that's when they're split apart. When they're condensed, it looks like this. So you can break these apart if you wanted to. Break this apart, write that section, and then you can do this and write that section and then go ahead and do the exact same thing. But a lot of people will solve this a little bit differently where they'll try to just do it all at once. And since you have 2 in 1, it's kind of weird. You're going to have to keep that in mind. So we're going to try it. I'm just going to give you a little bit demonstration about how this works. We're going to subtract 4 here, and we're going to subtract 4 on this side as well, just like we would. And right now, you can see I'm kind of ignoring this part right here. So that's what I would do. But now, that's weird though, because I actually have another part of this, a second inequality. We're actually going to subtract 4 on this side as well. So we're just going to do it for both right away at the same time. And so this is going to give us 0 is less than or equal to 3x, which is less than 15. Okay, cool. Now, again, I want to just pretend like this isn't there. And I'm just going to divide by 3 to get that x by itself and divide by 3. But I have this other one over here on the left, so now I'm going to bring that back and I'm going to pretend like it is there now. And because it is. And so then I'm just going to divide everything by 3. So this will be 0 is less than or equal to x, which is less than 5. So now that is my answer. Now that means, just the way it's written, you can even see here that x is in between what two numbers? X has to be in between 0, 0 and 5. So that really just kind of tells you how to graph it. It has to go, the solution region has to be between 0 and 5. So we're going to do that right now. 0, and you'll notice here this is less than or equal to. So I'm going to put a closed dot. And 5, and this one is less than there, so, and 5. It's everything in between right here. X even is in between the 0 and 5, so I know that. So that's an and inequality. That's how you put them together, or graph one of those when they're all condensed, and that's how you solve when it's in condensed form. Okay. But sometimes they get weird. So this is the last thing that I'll go through. Again, if you want to split it apart and that makes more sense to you, go for it. But I like to keep them together because it's just faster. So I'm going to solve this in the same way I just did the other one. But, so I want to, remember you're trying to get this x by itself. So if you're trying to figure out what should I do, you can ignore this to begin with and then just go from there. But in this case, it's add 2, and then I would add 2 here. Because I have 2 of these though, 2 inequalities, I'm going to add it on the other side as well. So now I have 30 greater than negative 10x greater than or equal to negative 5. Okay, now lastly I need to get rid of this negative 10. That's what the x. So I'm going to divide by negative 10. Divide by negative 10. However, over here, I also have to do that. But again, whoops, on my negative, there we go. Divide by negative 10. I want to make sure, because I'm dividing both sides, in this case, all 3 sides, by negative 10, I'm going to have to flip my inequality. So I'm going to do that right here. So this will be negative 3. This will be less than now. X, which is less than or equal to, and then this would be a half, or 0.5. So once again, I want to graph this. X has to be between negative 3 and 0.5. So this would be open circle. And then at 0.5, right, that's halfway between 0 and 1. That's less than or equal to. So we're going to do a, right there. I guess make that a little bit bigger. And then shade everything in between. And there we go. That's a condensed form. Kind of weird, but that's how you solve those, both and the or situation. So hope that helps and makes sense. Good luck.